Imagine this scenario. It is 40 degrees below zero outside. At that temperature, a standard nylon tent is not just uncomfortable, it is practically a death trap. It offers almost zero protection against the biting cold stealing the heat from your body. Yet, in those exact same conditions, people have slept comfortably for thousands of years inside a shelter made of frozen water. It sounds absolutely insane, doesn't it? How can being surrounded by ice keep you warm? The physics behind this paradox makes no sense on the surface until you zoom in and look at what is actually happening at the molecular level. Here is the secret that nobody tells you about survival. It is not about the material itself, it is about the air. Snow is not just frozen water. Snow is actually 90% trapped air and only 10% ice crystals. This distinction is critical because air is one of the absolute worst heat conductors in nature. To get technical for a second, the thermal conductivity of still air is incredibly low, just 0.024 watts per meter Kelvin. Compare that to solid ice, which conducts heat 100 times better than trapped air. This explains why grabbing a solid block of ice will instantly freeze your hand, but burying yourself in compacted snow can actually keep you alive. So, here's the million-dollar question. Why can you freeze to death touching a sheet of ice, but survive comfortably inside a wall made of snow? The answer completely breaks one of the biggest assumptions people make about cold weather survival. We tend to think that heavy, dense materials are better. But in this case, density is not your friend. It is your enemy. Solid ice is composed of molecules packed tightly together, creating a literal thermal highway that yanks heat straight out of your body and dumps it into the cold outside world. Snow blocks, on the other hand, are different. They contain millions upon millions of microscopic air pockets. Think of each tiny pocket as a thermal dead zone. When heat tries to escape from your body, it hits an air pocket and stalls. It cannot jump across easily. It gets trapped. You are essentially wrapping yourself in a massive, natural down jacket made of ice crystals. But wait, there is a logical problem here that we need to address. If snow is such a miraculous insulator, why do snowbanks feel freezing cold when you touch them with your bare hands? That comes down to heat transfer mechanisms. When your hand touches a snowbank, you are losing heat through conduction, which is direct contact. The ice crystals touch your skin and steal the heat. But inside a properly built igloo, you are not pressing your body against the walls. You are sitting in the center, separated from the cold walls by a layer of air. This means conduction is effectively neutralized. You have taken the biggest heat thief out of the equation. Instead, you are now dealing with radiation and convection, and this is exactly where the design of an igloo becomes an absolute genius of engineering. Let's compare it to a tent. A tent is made of fabric. It is thin, it is permeable, it has zero thermal mass. When you sit in a tent, your body heat radiates out, passes right through the thin nylon, and is lost forever. The wind strips away whatever warmth manages to cling to the fabric. You are fighting a losing battle, essentially trying to heat up the entire Arctic with just your body warmth. An igloo functions completely differently. Snow has a unique property. It absorbs heat slowly and releases it slowly. That 18-inch thick snow wall you build isn't just a wall, it is a thermal capacitor. It works like a battery for heat. Your body heat, the warm moisture from your breath, and even the tiny flame of a small candle release energy. Instead of vanishing into the void, that energy gets absorbed by the snow walls and then gently re-radiated back into the living space. It reflects your own warmth back to you. Drop a fire emoji in the comments if you have ever tried sleeping in winter conditions, whether it was in a high-tech tent or a primitive snow shelter. If you have, you know exactly how cold it can get. But we have measurements that prove just how effective this snow physics really is. Inside a properly constructed igloo, using nothing but your own body heat as a fuel source, the internal temperature can stabilize comfortably around 35 to 40 degrees Fahrenheit. Meanwhile, right on the other side of that wall, it could be 40 degrees below zero. That is an 80-degree temperature differential created with absolutely zero external fuel. That is the power of physics working for you. Now, this brings us to a critical mistake that almost everyone makes when they try to build a snow shelter for the first time. Logic tells you that if you want to stay warm, you should seal every single crack and crevice to keep the heat inside. You might think you need to make it airtight, That assumption is not just wrong, it is dangerous. You absolutely need ventilation, but perhaps not for the primary reason you are thinking of. While you obviously need fresh oxygen to breathe, the more immediate threat to your thermal survival is actually water vapor. Every time you exhale, you are releasing moisture into the air. In sub-zero temperatures, that moisture does not just float away or evaporate. It hits the cold walls and instantly freezes, forming a layer of frost. Over a few hours, that frost builds up and turns into solid ice. Remember what we said about ice? Ice conducts heat efficiently. So, if you seal yourself in, you are slowly turning your perfect insulator into a giant heat sink that sucks the life out of you. To prevent this thermal disaster, you need a small vent hole placed strategically at the very top of the structure. This tiny opening allows the warm, moisture-laden air from your breath to escape before it has a chance to freeze onto the walls and ruin your thermal barrier. Let me paint a clearer picture of why this works. The Inuit people, who have mastered this engineering over thousands of years, always place the vent at the peak of the dome. Since warm air rises, the humid, stale air naturally flows up and out. Simultaneously, fresh, breathable cold air sinks down but gets warmed up by the ambient heat before it reaches you. It creates a perfect, continuous convection loop powered entirely by the laws of physics. Coming up in a moment, I am going to share a specific 30-second rule that will determine whether your shelter ends up being a cozy furnace or a frozen coffin. But before we get to the build process, you need to understand why the shape matters. An igloo is a dome. It is always a dome. This isn't just about style. It is about thermal efficiency. A dome is mathematically the most efficient structure you can build to retain heat. Here is why. Heat rises. In a standard rectangular shelter or a cabin with a flat roof, all that precious warmth you generate floats up and accumulates at the ceiling, far away from where you are sleeping. Then it radiates out through the large, flat surface area of the roof. It is essentially wasted energy. In a dome, however, the physics changes. As heat rises, it hits the curved ceiling and circulates. It spreads evenly across the curved surface, pushing the warmth back down towards the center. There are no cold corners for freezing air to get trapped in, and no flat surfaces where heat concentrates and escapes uselessly. Furthermore, a dome minimizes surface area for a given volume. This is a crucial concept. Less surface area means less exposure to the brutal cold outside, which translates to less heat loss. If you built a cube with the exact same interior living space as an igloo, that cube would have 30% more surface area. That means 30% more wall space bleeding your precious warmth out into the freezing void. But there is one specific architectural detail that most survival guides completely miss, and it is the secret to staying warm. It is the entrance tunnel. A proper igloo always has an entrance that is positioned below the floor level of the main sleeping area. This design takes advantage of air density. Cold air is significantly denser and heavier than warm air. Because of gravity, the cold air sinks down into that lower entrance tunnel and stays there. It cannot climb up into your living space. Meanwhile, your living platform sits higher up, where the warm air naturally accumulates. Think of it as a cold trap. You are essentially creating a moat of dense, frigid air that protects your warm pocket of survival. This is not just theory. You can actually measure it with a thermometer. The temperature in that lower entrance tunnel might be 20 degrees below zero, while just 3 feet higher in the dome, it is a balmy 40 degrees. That is a 60-degree difference within the same structure, achieved purely based on air density stratification. Okay, so by now you are convinced. Igloos are not just piles of snow. They are thermodynamic miracles engineered to keep you alive when everything else fails. But knowing the theory won't save you if you don't know how to construct one properly. So, let's break down the build process that actually works, backed by physics. Step 1 is all about material selection. You cannot just use any white stuff on the ground. You need dense, packable snow, not fluffy powder. Here is a simple field test. If you cannot make a snowball that holds together firmly when you squeeze it, you definitely cannot make an igloo. You are looking for wind slab, snow that has been sitting on the ground for days, battered by the wind and compressed by its own weight. This compression forces the ice crystals to interlock, creating a structural integrity that fresh powder simply lacks. Step 2 involves quarrying your building materials. You need to cut blocks. The ideal dimensions are roughly 18 inches long, 12 inches tall, and 6 inches thick. You don't need laser precision here. You can use a dedicated snow saw, a large machete, or even the flat edge of a ski. You are not trying to sculpt perfect marble bricks. Rough blocks work perfectly fine because, as we will see later, snow has a forgiving nature that allows us to pack the gaps. Step 3 is where the geometry gets critical. Lay your first row of blocks in a circle, roughly 6 to 8 feet in diameter. Then, and this is the part most beginners miss, you need to cut a ramp into that first layer. You are not building a cylinder. You are not stacking independent concentric rings like a wedding cake. You are creating a continuous spiral. This implies that each new block sits slightly higher than the one before it, constantly leaning inward at an angle of about 15 degrees. This spiral technique ensures that every block is supported by the one below it and the one beside it simultaneously. Watch what happens next, because this is where gravity usually wins if you are not careful. Step 4 is managing the angle. As you spiral upwards, you must increase the inward lean. By the time you are halfway up the wall, your blocks should be leaning in at a dramatic 30-degree angle. You might think they will fall, but they won't. You are building what architects call a catenary curve. Imagine holding a chain by its two ends and letting it hang down. That shape is a catenary. An igloo is essentially that same shape, but inverted. It is structurally self-supporting because the forces are distributed downwards through the curve, compressing the blocks together rather than pulling them apart. Step 5 is the moment of truth, placing the final block, the keystone. This block must be shaped carefully and dropped in from the outside. When it slots into place at the very top, it locks the entire spiral together. There is no mortar, no wooden beams, no internal supports. It is just pure physics and compression, holding tons of snow above your head. Finally, step 6 is insulation detail. Take loose snow and pack it tightly into every single gap and crack between the blocks. This process is called sintering. As you pack the snow, the pressure causes the ice crystals to bond together, turning your shelter into a seamless, windproof monolith. After the walls are solid, dig your entrance tunnel. Remember the cold trap we discussed? Dig the floor of the tunnel lower than the floor of the igloo, angling it down and then back up into the living space. And do not forget to cut that crucial small vent hole at the very peak. And here is that 30-second rule I promised earlier. It sounds trivial, but it is the literal difference between life and death. Once you are settled inside your snow fortress, you must take 30 seconds every few hours to reach up and poke that small vent hole clear. Why? Because the warm, moist air rising from your body will hit that hole and freeze instantly upon contacting the outside air. If you ignore it, frost will rapidly clog the vent. Once that happens, moisture gets trapped inside, oxygen levels drop, and carbon dioxide builds up. Your warm, dry shelter will turn into a suffocating, solid ice freezer. Do not skip this step. Now, let's talk about build time. With practice, you can construct a life-saving shelter like this in about 90 minutes. Once built, if the temperatures stay below freezing, it can last for weeks. And listen closely. If this video brings value to you, hit that like button. If we reach 20,000 likes, I am flying up north to build one of these equipped with a thermal imaging camera. I want you to see exactly where every single degree of heat goes, visualizing the invisible physics we are discussing today. But here is what separates the beginners from the true experts. It is understanding phase change energy. Most people think snow is just insulation, like the pink fiberglass in your walls. But it is much more than that. It is a heat battery. This happens because of a continuous cycle of melting and refreezing. When the inside of your igloo warms up slightly from your body heat, the innermost layer of the snow wall begins to melt just a tiny bit. Here is the physics. Melting is an endothermic process. It absorbs energy. A lot of it. That heat energy gets locked into the phase change as the water turns from solid to liquid. Later, when you sleep or stop moving and the internal temperature drops slightly, that thin layer of water refreezes. Refreezing is exothermic. It releases that stored energy back into the space. Your igloo is actively absorbing heat spikes and releasing warmth slowly, stabilizing the temperature without you lifting a finger. This sophisticated mechanism is exactly why igloos maintain a comfortable warmth with just body heat, while a nylon tent's temperature plummets the second you stop shivering. You might be thinking, this is fascinating, but it only works in the extreme Arctic. That is completely wrong. Snow shelters work in absolutely any condition where snow is packable. It does not matter if you are in the high mountains, deep forests, or high deserts after a winter storm. The laws of physics do not care about your GPS location. They only care about structure, thermal mass, and trapped air. You now possess more knowledge about cold weather thermodynamics than 90% of winter campers out there. You understand why density defeats you, why the dome shape saves you, and why the very material that can freeze you to death is the same one that can keep you alive if you know how to trap the air inside it. Want to see this theory put into practice? In the next video, I am going camping with some friends, and we are going to test out these exact principles in the field. Let me know in the comments what specific part of winter survival interests you most, and make sure you subscribe so you do not miss the field test.